Welcome to Mathematics Lecture series. The topic is application of function lecture number 8 in applied calculus series. Before the start of lecture, I request you kindly click the bell icon to subscribe the channel and like the video and share the video. Application of the function. So example number 1, a rectangular fence is to be constructed so that its length is 3x plus 2 and width is x meter. This is a figure for rectangular fence. Its length is 3x plus 2 and width is x. Find the p is the function that gives the perimeter. We have to find the p of x perimeter. So sum of all sides is equal to perimeter. Perimeter is the sum of the sides of any polygon. Now for rectangular we have x here 2 times width, here x, here is also x, 2 times of x plus length 3x plus 2 also add in, so 2 times of 3x plus 2, 2 into 3 6x, 2 into 2 4 and 2x, 6x plus 2x 8x, 2 plus 2 into 2 4. So perimeter is 8x plus 4 meters. Another example, there is a colony of bacteria is placed into a growth inhibiting environment. The number of bacteria present at any time t in hours is given by n of t 120 t plus t square by this quadratic equation. Growth inhibiting environment, the number of bacteria present at any time t, here t represent time. Find n of 0, n of 1, n of 10, interpret your results. Simple that in that equation, which is number of bacteria shows any time t, apply 0, so 120 times 0 1000. This means that at the beginning t equal to the number of bacteria in the colony is 1000. After 1 hour, so apply t is equal to 1 in that equation, 1020 t square 1021. This means that after 1 hour, the number of bacteria in the bacterial colony is 1021. After 10 hours, so time, put in here time t is equal to 10, 1020 t is equal to 10. Here t square 10 square, so 1020 13, and this means the number of bacteria in the colony after 10 hours is 1300. Another example, when a car is moving at x miles per hour and driver decide to slam on the brakes, the car will travel x plus 0.5x square foot if car travel 175 foot after the driver decided to stop. How fast car moving? Here, when car is moving at x miles per hour and the driver start, the car will travel that. If car travels 175, so of course that one is equal to 175. Driver decides to stop. So here we multiply equation x here shows the how fast was car moving. So multiply 2 with that equation, so we will have 0.5 means 1 by 2, 2. 2 will cancel 0.5 x square, here 2x 175 is 2, so subtract both sides 35t, so here is equal to 0. Solve this simple quadratic equation, we will have 70.8, that is approximately 80 miles per hour. So car is moving 18 miles per hour. Another example, a person weighing 150 pounds on earth has weight by given by this formula W of T24 24 4000 plus D square miles above the earth's surface. Find W at 0. W at 0, so D replaces 0, we will have after calculating 150. This means that weight of the person under 150 pounds. Number B, how much this person weighed while flying in the airplane at 29,000 feet. So 1 mile is equal to 5280 feet. So here D is equal to 29 for to transfer into miles. So we will divide with 5280. So 5.5 miles. If 1 mile is equal to 5280 foot, so 1 foot is 1 over 52 5280 1 over 52 5280 mile. So that's why we divide here 5.5 miles. So D is equal to 5.5 putting in the formula. So W is 24. D is equal to 5.5, so it becomes 4005.5 square. So 149.6 is the weight when the person while flying in the airplane at 29,000 feet. Similar astronaut orbits the Earth at an average of 80 miles above the surface. The weight pounds on the Earth. How much does he weigh while in orbit? So in fact this is D is equal to 80. Just put in this formula. D is equal to 80 and after get 144.2 pounds. Number of degrees D in each interior angle of a region of polygon n sides are D 180 and minus 30 over n. Use this formula to compute number of degrees for a polynomials of sides 3, 4, 5 and just n is equal to 3 means 3 sides polygon. So n in that formula replace 180, 360, 60 degree. Each angle of equilateral triangle is 60 degree. And that formula we put n is equal to 4 means square. So here n replace with 4 you will have 90 degree. So each angle of square is 90 degree. If n is equal to 5 we will have 108 degree. Each angle of regular pentagon is 108 degree. 6 in hexagon here in that formula and replace 6 186 minus 360 over 5 144 degree. Each angle of regular hexagon is 144 degree. This is valid only for regular polygon. Here the following formula used to know the depreciated value of an atom D C minus C minus S T over N. Here D shows the depreciated value after T years. C is the original cost, N is the useful life in years, and S is the scrap value, resale value. What will depreciated value? We have to find the D of the machine after 8 years. Means here N is T is equal to 8 years when it was purchased for. So S is equal to $4. C is equal to 34,000 sell, and its present value scrap value is $400, and the useful item is time is 15. N is equal to 15. Put the formulas that C 34 minus C 34 here T is equal to 8 400 divided by 15 we will have 1800. The depreciation value of the machine after 8 years was $1,800. In that problem we are told that after 15 years the value of the machine is $400, and we asked that under this condition what was the value of machine after 8 years of its purchase. Observe this data. Consider following data on length y and edge x of the alligator. So x is a 1 2, so y is equal to 1 4 2 point. This is 1.4 is y1, 2.6 is y2, x1 is 2. As a relation between two variables linear, find the length of the alligator when it is 4 years old. The age when alligator is 6.8 feet long. From geometry, we know that slope of line is m y2 minus y1 x2 minus x1. So here y2 is 2.6, y1 is 1.4, x2 is 2, x1 is 1. So we will have 1.2. This relation between length and edge of alligator is. So here in that equation, y minus y1 is equal to mx minus x1. So we will have this y is equal to 1.2 0 point this that relation. Here x shows the alligator is 4 years old, then its length y is equal to 1 point x shows the edge 0.5 feet. The area is 6.8 feet long, then 6.8 1.2x 0.x is equal to 5 of 1 by 2 years. So x shows the edge of the alligator, and we will have workers at a fast food restaurant earn $5 per hour for the first 40 hours in a week. And X shows the number of hours. So 0 to 40, from the 0 to 40 hours, a worker would be have 5x would be paid. When a greater than 40 per hour, and now in a week, and then $7 per hour for additional work, additional hours. So for the additional hours, first 40 hours, it will be paid $5. So 5 into $40, 200 totals, plus as dollars per hour for each extra hour over 50. Now the extra hour will be x minus 40. In fact, this becomes x minus 40 is the extra hours, and then earning would be 200 plus 7.5 x minus $40 according to situation. After simplification, we have p of x. We simplified 7.5x, 7.5, 40 is equal to 100, 7.200 plus 7 minus 40 will have just 200 after for x greater than 40. So thus 2p's function p is given by this formula. First 40 hours 5x, and after 40 hours 7.5 minus 100. Now find what would be paid for 35 hours. In fact, 35 hours it belongs to that domain, so we use just 5 into $30, 175 hours. Find the 45. We have the x greater than 40, 7.5x. Here x is 45 minus 100. After simplification, we have $237.5. Another example, the monthly charge for water in a small town is given by 18 for 0 to 20 monthly charges. 18 was 0.x for x greater than 20. The monthly charge of water in a small town by this given by this two piece when x is 100 of gallons and f is the dollars. Find the monthly charges for each of the following. Use a 30 gallon 300 4,000. Since x is in 100 of gallons, since 1 unit of gallon will be 1 over 100 0.01. The 30 gallon will be equivalent to 0.30. You now according to given domain f of 0.3. So 0 belong to that domain. This just $8. Since x in 100 of gallons, 3000 gallon will be equal divides 30 of units. Now according given domain f30 is belongs to that x greater than 18 plus 0.130 minus 20 $19. Since x in 100 given 4000, again divide 140 of units. So by this given domain x greater than 20, we use 18.0.40 minus $20. 1 gallon is equal to 4.546 liters. So we have solved some example on the application of the function. I request you kindly subscribe the channel as you find more videos on the calculus and other mathematics topics, and like the video and share the video. Thank you.